Ladies and gentlemen, this is your well-rounded math teacher, Mr. Pickar. We're working on Unit 2, Video 4, Notes, Solving Absolute Value Inequalities. So basically, what we want you to be able to do for learning targets is set up and solve absolute value inequalities, and you can graph the solutions of absolute value inequalities. Okay, to start off with here, solving absolute value inequalities combines these strategies used in, number one, solving and graphing compound inequalities. A compound inequalities, it's either an and or an or statement, so we're going to be getting into that. And then number two, solving absolute value. Absolute value equations. Both of these you've done, we're just going to kind of combine them together, put them together. Every absolute value inequality is a compound inequality. Two separate inequalities come from when you split up the inequalities once the absolute value is isolated. So we got to isolate our absolute value. We'll kind of talk about that in a little bit here. So first you isolate the absolute value, following all the same steps that you did when isolating absolute value equations when you're solving those, and then you split and set the two negatives and the positive. Set to a negative and then set to a positive. We'll kind of explain that in a second here. Okay, so the new stuff, what you're going to be learning today. Once the absolute value is isolated, that's kind of the key. You got to get whatever's inside your absolute value isolated. I'll just say greater than 5 for whatever reason. This has to be by itself before you can break them up. You choose whether it will be an and or an or statement depending on your inequality symbol. If you have a greater than symbol, greater than or equal to, then it's going to be an or statement. So one of the things to do with this, if you see a greater symbol, greater than, that's how I would say that. So greater than is an or symbol. Or statement, basically. Less than is an and statement. Okay? Graph both and keep the intersection. Less than, this is how I say this, less than. It's a little shortcut or a little trick to remember that it's an and statement. Now, if it's an or statement, you're working with this absolute value inequality. What happens is you can have some graph where your graphs are going to go in opposite directions. With an and statement, they're going to be going in the same direction, and it ends up just being in between the 2 points, and that's what they're talking about when it's an intersection. So your solution is in here somewhere. If you get a point outside of that solution, it's no solution. With an or statement, it could be either one of these graphs. So if I have this point right here, that would make it a true statement. If I had something in between the two, then it's not part of the solution, where if it's part of this graph, it's also part of the solution. So that's the difference between an or and an and statement. So we're going to jump right into this. Example 1. Here's our example up here that we're going to be working with. Here's our absolute value part of it. It's an inequality. It's greater than, so it's going to be an or statement. We'll get to that in a minute for the most part. But you have to isolate. Right here it says isolate the absolute value. We have to get this by itself. So that's the first thing we do. We add 10 to both sides. And I get 2x minus 3 is greater than positive 5. Okay, good. First of all, this is positive over here. That's good. We have this isolated. Now we can really look at the symbol and see if it's going to be an and or an or statement. In this case, it will be an or statement. Okay. So now it's a matter of splitting it up, and they kind of did it down here for you. The first part, it's 2x minus 3 is greater than 5, and that's what we have right here. And then the second part of it, when we put in a negative 5 right here, you have to flip your inequality symbol. When you change this number right here, whatever it is, greater than or less than or equal to, whatever it is, you have to change it to a negative. You have to flip your inequality symbol. So here we're saying greater than. Now we're saying we're flipping it to less than. And because it started out as greater than, the or statement is what goes in between these two. And then these are the two inequalities we solve and then graph. So solving this one over on the left, I'm going to add 3 to both sides, and I get 2x is greater than 8, and finally divide both sides by 2, and I get x is greater than 4. So that's one of my solutions. Or, adding 3 again to both sides, I get 2x is less than negative 2, divide both sides by 2, and I get x is less than negative 1. So this is my solution. Now you should graph it and see what it looks like. I'll write it down here. X is greater than 4, or x is less than negative 1. You don't have to be too specific on the number line. We'll throw a 0 in the middle. 1, 2, 3, 4. It's greater than. It's not greater than or equal to. It's just greater than. So I'm going to leave it as an open circle. I'll put a 4 down here. It's greater than 4. Or negative 1 is right here. It's less than negative 1. Not less than or equal to, so I'm just going to leave it as an open circle. And we go in this direction. Now this is typically what an OR statement is going to look like. 2 graphs going in opposite directions. So I have all these solutions over here. I have all these solutions over here. But 0 in this case would not be a solution for this absolute value inequality. Okay? But it looks like a compound inequality when you're done with your answer here. Okay? And that's kind of how they work, whether it's an AND or OR statement, and then solve both sides. So, some special situations. Okay? It talks about special situations, just like when you were learning about absolute value equations. If you isolate the absolute value and it's greater than or less than a negative number, it's a special situation. Well, here's an equation, okay? When I take the absolute value of this 4x plus 2, it's going to be positive, so it's never going to equal negative 10. This is definitely no solution. And you learned that when we solved absolute value equations. Okay, these two are inequalities. Now when I take the absolute value of this, it's going to be a positive number. Can a positive number be less than negative 10? No. So in a situation like this, if you isolate your absolute value and it's less than some negative number, this is also no solution. See here, the last one. No matter what, when I isolate this and take the absolute value of it, it's going to be a positive number. Well, greater than negative 10. It doesn't matter what I have inside here. When I take the absolute value of it, it's going to be positive. A positive number is going to be greater than negative 10 every time. So in this case, all reals. You wouldn't even have to finish solving it. You could just say all reals. Just like over here, you could right away, once you isolate the absolute value, you could say no solution. Or you could use the all real symbol like this. Okay, moving along here. So I'm going to do a bunch of examples of solving these absolute value equations, or absolute value inequalities. First thing always, A here, you're going to isolate your absolute value symbol, and we did, it's already isolated. So now I can go ahead and look at this. This is the less than, or less than. It's going to be an AND statement. And I can split it up into the two, into a compound inequality now. The first thing you'd say is this. Everything inside there, 5x minus 10, is less than 15, basically what you're given. The other one that you're going to pull out of it is when this would be negative. So 5x minus 10, you're going to switch the symbol. Whenever you switch that 15 to a negative 15, you're going to switch the symbol too. So instead of saying less than, I'm going to say greater than negative 15. And if I solve this compound inequality now, it's going to be the solution for this absolute value inequality. And then graph it, and you're pretty much done. So solving this side, adding 10 to both sides. 5x is less than 25. Divide both sides by 5. X is less than 5. And adding 10 to both sides here, I get 5x is greater than negative 5. Divide both sides by 5. Now, there's a negative involved here, but I don't have to flip my symbol because I'm dividing by a positive 5, not a negative 5. So I end up with x is greater than negative 1. So, this is my solution. Now I should graph it. This is 5 and this is -1, so be careful when you're graphing this on the number line. 1, 2, 3, 4. Here's 5. It's less than 5, so it's going to be going in this direction. Over here, -1, -1, -2, -3. We'll put the -1 right there. It's greater than -1, so it's going in this direction. And when it's an AND statement, it should be an intersection between the 2 points. So there we go. There's your solution. You just graphed it. Now you can rewrite this. This is fine for an answer, but if you really know what you're doing, if it's an intersection like this, -1, x, and 5, and x is less than 5 up here, so yeah, x is less than 5 here, but -1 is less than x. Whenever you write it all together like this, with your compound inequality, first of all, it has to be an AND statement. You have to go from smallest to largest. All your solutions x are basically between this -1 and +5. That's how you write it. These two symbols are always both less than, if you write it correctly. Okay? So either one of these answers, I would accept. This tells me you know what you're doing. Okay. Here's another one. Negative. Okay, absolute value is isolated. I don't have to do anything to both sides, so I can split this up right away. I look at my symbol, it's less than or less than, so it's an AND statement. So I'm going to pull this -7x out of there and say it's less than 14. And I'm going to say that -7x is also greater than -14. So whenever you turn it into a negative, you have to flip the inequality symbol also. You have to be careful with this one because we're dividing both sides by a -7. So when I divide by a negative, I flip my inequality symbol. So this becomes greater than. These cancel out and x is greater than -2. And dividing by a negative again here, flip your symbol. Instead of greater than, now it's less than. These cancel out and x is less than +2. It's an AND statement, so when we graph it, it should be an intersection in between the two. So if it looks like an OR statement, we maybe made a mistake somewhere. Here's 0, 1, 2. -1, -2. Now, first of all, it's greater than -2. It's less than +2. So it's right in, your solution is right in between the 2 and the -2. You can write this as your answer, but if you know what you're doing, smallest to largest, all my solutions are between -2 and +2. X represents all my solutions. So right here it's less than 2. And if you flip this, -2 here and x here, you'd flip your symbol, it's less than also. There we go. Smallest to largest, first of all, -2, right here all the way up to +2, and then x is all my solutions in between. This is how you'd write it all together as a compound inequality. Okay. Getting a little bit more complex here. I got to isolate my absolute value. Now remember, we talked about this 4. It looks like we should distribute it through there. But when you're working with absolute values, sometimes it works, sometimes it doesn't. So I wouldn't distribute that 4 through there. To get this by itself, first we're going to add 9 though. And 4, absolute value, 3x minus 6 is greater than 36. And I know if I distribute the 4 here through, it would work. But it doesn't work all the time, so I'm just going to stick to, when you get your absolute value by itself, don't multiply or distribute anything through there. So being it's 4 times the absolute value, I'm going to divide both sides by 4. Absolute value 3x minus 6 is greater than 9. Okay, here it is. I isolated my absolute value. So now it's just a matter of creating your two inequalities, deciding if it's an AND or an OR statement, and then solving those two inequalities. It's greater than, so I'm going to use OR. And first of all, 3x minus 6 is greater than 9. Or, the other part of it would be 3x minus 6 is less than -9. Remember, when I change this positive to a negative, I also have to flip the inequality symbol around. And then there's your compound inequality. You solve that, and then you're done. So, adding 6, 3x is greater than 15, divide by 3, x is greater than 5. or adding 6, 3x is less than negative 3. Divide both sides by 3. I don't want to flip my symbol here because I'm dividing by a positive 3 on both sides. So x is less than negative 1. Okay, here's the number line. It's an OR statement, so we're probably not going to be able to write my answer together as one big inequality. So we're going to leave it like this. Be careful. Here's 0, 1, 2, 3, 4, 5 is on this side. Negative 1, 2, 3, 4. Negatives on the left side. So the first part of it, x is greater than 5. It's not greater than or equal to 5, so I'm not going to color in that point. And then x right here is less than 1. This is a typical OR statement. My solutions are going in opposite directions, or my graphs are going in opposite directions. So negative 2 would be a solution because it hits the graph right here. But positive 2 would not be part of this solution. It's got to be part of one of these two graphs. And there it is. There's my graph, and that's how I'd write my answer. Remember, with an OR statement, you can't write them together. Okay, we got some fractions in here. That's good. This is D. Remember, we're going to get this absolute value of 8x minus 16 by itself first before we can split it up into the two compound inequalities. So we're going to subtract 11, 3/4, 8x minus 16. These cancel out. It's less than 6. Okay, with this fraction, you can multiply both sides by the reciprocal of 3/4 or by 4/3, and it would work. I'm just going to multiply by 4 first, breaking it up into 2 steps. That works for me. These 4's cancel out. 3 would be left. 8x minus 16 is less than, in this case, it's 24. And then, remember, you can distribute through here. I'd rather have you not do that because it doesn't work all the time. So I'm going to divide both sides by the 3. The 3's will cancel out. Absolute value of 8x minus 16 is less than 8. Okay. Now I can split it up. I'll put this down here somewhere. First, what we have, 8x minus 16 is less than 8. It's less than, so it's going to be an AND statement. Less than, little shortcut there. 8x minus 16 is greater than, now we're going to flip it, negative 8. So solving these two bad boys, plus 16, 8x is less than 24. Divide both sides by 8, and x is less than 3. And bringing that down, adding 16 to both sides, 8x is greater than 8. Divide both sides by the 8, and x is greater than 1. Okay, so graphing this, it should be an intersection. Here's 0. 1, 2, 3, 4, we'll go up to 5. Here's 3, and here's 1. Now, first of all, it's less than 3. And it's greater than 1. So it's in between the two because it's an AND statement. Now, remember, we can write this all together as 1, starting with the smallest. X is in the middle, going to the largest. You can see right here, x is less than 3. You just put another less than symbol in there. If you flip this around, you'd have to flip the inequality symbol also. This would be 1 is greater than x, and that's kind of what you see right here. This is how the proper way to write your answer, I guess you'd call it. Okay. E. Okay, we have a fraction there. We're going to multiply both sides by 4, but first, x inside the absolute value is part of this whole fraction. So we're going to get rid of the 35 first before we start working with this fraction. I'm going to add 35 to both sides. 3 absolute value of 2x plus 4 all over 4 is greater than or equal to 30. Okay, now I just have this fraction. So in order to get to this part of the fraction, the numerator, I'm going to multiply both sides by 4 over 1, which is the same as multiplying by 4. These would cross cancel out then, and you end up with 3 times the absolute value of 2x plus 4 is greater than or equal to 120. Okay. A little bit of a complex problem here, but it's working out. I'm multiplying by 3. If this was parentheses, yes, I'd use the distributive property. But because it's absolute value, I'm just going to divide both sides by 3 to get rid of that. Absolute value of 2x plus 4 is now greater than or equal to 40. 120 divided by 3 is 40. So hey, here it is. It's isolated. It was a little bit work to get to it, but now I can break it up into the two inequalities. First of all, greater than or equal to. Greater is an OR statement. 2x plus 4 is greater than or equal to 40. Or 2x plus 4 is less than or equal to negative 40. Flip that symbol when you do the negative part of it. Okay. Now, just solving this we just went from our absolute value inequality to a compound inequality, just solving these two inequalities. Subtracting 4, I get 2x is greater than or equal to 36. Divide by 2, and I get x is greater than or equal to 18. Or, subtracting 4, I get 2x is less than or equal to negative 44. Divide by 2, x is less than or equal to negative 22. So we're done except for the graphing. And graphing this, okay, they're bigger numbers, so I'm just going to do this. We'll say, here's 0. 5, 10, 15, 20, 18 is roughly right here. Now it's greater than or equal to 18, so I'm going to circle that 18 and color it in. Greater than or equal to, I'm going to the right. Negative 5, 10, 15, 20, so 22, negative 22 would be right about here. It's less than or equal to negative 22. So smaller than that, less than that, it would be going to the left. And this is a typical OR statement. So x is greater than or equal to 18, or x is less than or equal to negative 22. You can't write an OR statement together like you can an AND statement because they're going in opposite directions. The only time you can write them together is if it's an intersection. They're going in the same direction. Okay, last one here. It looks super complicated, but it's really not that bad. We're just going to go piece by piece. Now I got everything above 4. So in order to get to this part of the equation, I'm going to multiply by 4 over 1. Multiply by 4. Now these 4's will cancel out. And I end up with 5, absolute value of 10x plus 5 minus the 3 is less than or equal to 36, 72. Okay. Okay, to get to this absolute value, I'm going to add 3 and divide by 5, but this is all together right now because you're multiplying them, so we're going to add 3 to both sides first. 5 absolute value of 10x plus 5 is less than or equal to 75. Once again, not going to multiply 3 by the 5. Just get used to when it's an absolute value, if you're multiplying, divide to cancel that 5 out. Absolute value of 10x plus 5 is less than or equal to 15. And now we can break it up into a compound inequality, this absolute value, because we have the absolute value right here isolated. Less than, this is an AND statement. So it's 10x plus 5 is less than or equal to 15. And 10x plus 5 is greater than or equal to negative 15. When you go from 15 to negative, flip that inequality symbol. And then solve, and we're done. So subtracting 5, 10x is less than or equal to 10. Divide both sides by 10. X is less than or equal to 1. And subtracting 5, I'm going to get 10x is greater than or equal to negative 20. Divide both sides by 10. And I get and x is greater than or equal to negative 2. Okay. So it's an AND statement. We should be able to write it together as one compound inequality. Here's 0, 1, 2, 3, 4, 5. We'll say 1. It's less than and less than or equal to 1. Negative 1, 2. Here's negative 2. It's greater than or equal to negative 2, so we're going to circle it and color it in. Greater than is going this direction. It is in between the two. So yes, you can write your answer like this, but the way I would prefer you to write your answer, going from smallest to largest, negative 2 to 1, all my answers right here represent x. It's less than or equal to 1, so it should be negative 2 is less than or equal to x. Like I said, remember, if you flip this, turn these around a little bit, negative 2 and then x, you'd have to flip your inequality symbol too and say instead of greater than, less than. That's why it's always less than or equal to symbols inside your answer here. And that's it. You guys can go ahead and start working on your 2-4 practice worksheet. If you have questions, don't be afraid to come up and ask. Peace out, Girl Scout.